All right, let's say that you're traveling over a hill in your car. You know how when you go on traveling in a car really, really fast over some bumps, you kind of feel like your heart, your stomach or whatever ends up in your chest. You know, you're going so fast. Well, that's related to this, how fast you're going over these bumps in what we would call a vertical circle, where the center of the circle is below you. Let's say, so this is the bump, this is the road, here's your car, very fancy. And this is part of a circle. It's weird to think of this as part of a circle. But it is, and the center is down there. And it's 12 meters below you in this example. In a question like this, you can go as slow as you want. The people behind you might get upset, but you can go as slow as you want. You can go up there and park. So there's no limit to how slow you can go, but there is a limit to how fast you can go and still continue in circular motion, still keep your wheels in contact with the car. Because if you go too fast, you'll become airborne. You'll become a projectile. If you go too fast over this thing, you'll go into the air and go into parabolic motion, not circular motion. So we're going to calculate that maximum speed that you can travel and still continue around in circular motion with the wheels in contact with the road. I'm going to say that again, the radius is 12 meters. If you draw a force diagram for this one, dot represents the car. Of course, you have the weight of the car straight down. And then you have a normal force pointed up. The normal force is the force of the road up on the wheels. I'm going to draw the normal force shorter than the weight. Why? Because you come back down again in a circle. That means that the net centripetal force is always pointed towards the center of the circle, which is below you. These cannot be equal and have you turn. You can't have balanced forces and not change direction. So the fact that you're changing direction down like that, that kind of curve, means that that force must be greater than that one. All right? So your net centripetal force equation is always the one pointed towards the center of the circle minus the one pointed away. So that's Fg minus n. All right, this is centripetal. Centripetal meaning towards the center. So towards the center, that's that force minus the one pointed away from the center. And that will equal mv squared over r. And the faster you go, the bigger the right-hand side of the equation gets. The faster you go, the bigger the right-hand side of the equation gets. If the right-hand side of the equation gets bigger, the left-hand side must get bigger, equal sign. If that gets bigger, that must get bigger. Well, just because you're going faster, it doesn't change your weight. So the only way to make this left-hand side bigger is to make that smaller. Again, if you're going faster, the right-hand side gets bigger. Equals. So the left-hand side must get bigger. Well, that's not changing. That's just your weight. So the only way for that to happen is for the normal force to go down. So the faster you go over the hill, the less the normal force. Until you get to the point where if you go really fast, the wheels might leave the ground. Which means there is no normal force because your wheels aren't touching the ground anymore. So find that speed that makes the normal force 0. So what's the first speed you're going to reach where your wheels are just going to leave the ground? Yeah, you could go faster, that's bad. But what's the speed where it would just begin? That's your maximum speed. If you go any faster than that, you're going to go into the air. Woo! Projectile motion. So, again, it's actually a fairly easy calculation once that's set equal to 0. So maximum speed, and still go in a circle. Why do I know we're going in a circle? Because I'm still using mv squared over r, which only applies to a circle, not a parabola. So you're not airborne, you're just going to get there. You're almost airborne. So this is mg, weight is mg, equals mv max squared all over r. Your m's cancel. solve for Vmax. That equals the square root of Rg, which is the square root of 12 times 9.8. Because I said that this is 12 meters down. Right? And let's go ahead and calculate that. Square root of 12 times 9.8 is 10.8 meters per second. 10.8 meters per second. What does that mean? If you go 10.9 meters per second, your wheels are going to leave the ground. You'll become airborne. If you can go slower, you just don't want to go faster.